So what we're going to start doing is solving a system of equations that has three variables. And in order to solve for three variables, you need to have three equations. This carries on to larger numbers of variables. If you have a system with 4 variables, you need 4 equations to do it. If you have a system with 5 variables, you need 5 equations to do it. So we're going to start with some relatively easy ones. The kind that we're going to start with are right here, and what this is called is a triangular system. And the reason why it's called a triangular system is because it is actually triangle shaped, if you notice. See how this is a triangle? And what it means is you're going to have one equation with all 3 variables, one equation with 2 of the variables, and one equation with 1 of the variables in this second equation. And these are very easy to solve. It is all substitution. So no addition, no elimination, all substitution. And so the key is just don't make math errors along the way. So the first thing you're going to do is go to your equation that has 1 variable, and you're going to solve for that variable. So the equation with 1 variable is negative z equals negative 3. And I'm going to solve for z. So divide both sides by negative 1, and I get z equals 3. Now I know z. So I'm going to go to the equation that has the y and the z, the 2 variable equation. And what I'm going to do is plug or substitute z equals 3 into that equation, and I'm going to solve for y. So I've got y plus 2 times 3 equals 5. So this is y plus 6 equals 5. Subtract 6 from both sides, and we get y equals negative 1. So now I know what y is. All right, next thing I'm going to do is go to the equation that has 3 variables in it, the x, the y, and the z. And I'm going to substitute z equals 3 and y equals negative 1 into that equation, and I'm going to find x. So all substitution. So when I go to this last part, I have x minus 2 times negative 1, because y is negative 1, plus 2 times 3, because z is 3, equals 9. And I'm going to simplify. This gives me x plus 2 plus 6 equals 9. Combine like terms, and I have x plus 8 equals 9. Subtract 8 from both sides, and I get x equals 1. Now, the way that I'm going to write my answer is similar to how I wrote my answer when I had just x and y. It's in parentheses with commas in between, but it looks like this. It's going to have 3 numbers. They're in alphabetical order. The x goes here, the y goes here, the z goes here. So x is 1, y is negative 1, and z is 3. And that's how you would give an answer for a system of equations with 3 variables in it. All right, so let's try another one. If we go to the bottom of the page, we have example 2. And again, this is all substitution. So the first thing, go to the equation that has 1 variable, and there's nothing to solve here because it tells us z equals 3. So we're going to take that. That's one of our answers. I'm going to put a little circle around that. Go to your equation with 2 variables and substitute z equals 3 and solve for y. So I have 2y plus 3 equals 1. Subtract 3 from both sides, and I have 2y equals negative 2. Divide both sides by 2, and I have y equals negative 1. So now I have y and z. I'm going to go to that first equation that has 3 variables, and I'm going to substitute y is -1 and z is 3, and I'm going to solve for x. So I have 2x plus 3 times -1 plus 2 times 3 equals 13. This gives me 2x minus 3 plus 6 equals 13. Combine like terms, and I'm going to get 2x plus 3 equals 13. Subtract 3 from both sides, and I get 2x equals 10. Divide both sides by 2, and I get x equals 5. Now I'm going to give my answer. It goes in the order x, y, z. So it's going to be 5, -1, 3. All right, let's try another one. So at the top of page 9 of our notes, this doesn't look triangular, but it is triangular. It's triangular in its nature, not necessarily its shape. And it's triangular because we have one equation with 3 variables, one equation with 2 variables, and one equation with 1 variable. So the first thing we're going to do is we're going to solve for x, because we have -x equals -2. Divide both sides by -1, and we get x equals +2. Substitute that value for x into the second equation, and we'll solve for z. So I have 2x, that should be 2 times 2, because x is 2, plus z equals 8, which gives me 4 plus z equals 8. Subtract 4 from both sides, and we've got z equals 4. Now we're going to substitute x is 2 and z is 4 into the first equation and solve for y. So I have x, which is 2, plus y, plus z, which is 4, equals 5. Combine like terms, and I have y plus 6 equals 5. Subtract 6 from both sides, and I get y equals -1. I want to give my answer in the order x, y, z in parentheses with commas in between. So this is 2, -1, 4. So once you have a triangular system, you can solve completely with substitution, and it is pretty easy. The difficulty comes when you have an equation like example 4. We cannot use substitution. Well, actually we can, but it's very difficult and cumbersome to use substitution to solve an equation or a system of equations such as this. It's not triangular. We have 2 equations with 3 variables and 1 equation with 2 variables. And we're going to have to use a different method, that being elimination or addition, in order to solve this. Now there's a strategy to do this, and it may not make a lot of sense as I just talked through the strategy, but as we go through repeated examples, it'll start to make more sense. What we want to accomplish is we want to transform this into a triangular system. So we want to come up with one equation with 3 variables, one with 2, and one with 1, so that we can use substitution. That's our goal. But that's not what we have right now. So here's what we're going to do. We're going to start eliminating variables. And in order to eliminate, we're going to use the elimination method. So what we're going to do is pick one variable to eliminate twice. And what that means is we're going to have 2 equations with the same 2 variables. In this example, since I already have an equation missing a z, what I would do is eliminate z again. And what I use to do that are the equations that have z in them. And I'll show you how we do this. So what I'm going to want to do is do that twice. So I get 2 equations with the same 2 variables. Now you know, because you've been doing this for a couple days, How do you solve a system of equations that has two equations with the same two variables? You can use elimination or substitution, just like you've been using the last few days. That's going to give you two of the variables. Then you're going to use substitution and go back to an equation with three variables, and you're going to figure out that third variable. So here's our second step. Use elimination addition to eliminate that variable twice. Each time you will use two different original equations. Obviously, one of them is going to be used twice because you only have three to work with. This step creates two new equations that have only two variables, the same two variables. Then you're going to use elimination or addition with your two new equations to solve for those two variables. And it's fine if you want to use substitution, but usually elimination is easier. Lastly, you're going to substitute those two known variables into one of the original equations and solve for the last variable. These problems are long, and the issue is not making a math mistake somewhere along the way. That's the biggest risk, because if you do that, your whole problem is shot, because now you're substituting a bad number into the rest of your equation. You're going to get a bad answer for that. So let's turn the page and we'll go through this example step by step. And in order to keep track of what you're doing, it's really important to use that arrow system that we talked about and write what you're doing so that we know. I find the easiest thing to do is label your three equations so that you don't have to keep rewriting them. So for example, I call my top equation, equation number 1. The second equation, whatever it is, number 2. And the third equation, I call it number 3. So I label them number 1, number 2, and number 3. I have one equation that doesn't have a z in it. I want a second equation that doesn't have a z in it. So what I'm going to do is use equations 1 and 2 to create an elimination of z. And the way I would eliminate z is I could multiply this second equation by -2. That would eliminate z. So I write equation 1 with an arrow, and I'm going to do nothing to it. And I'm going to write it out as it is here. I'm going to write equation number 2 times -2, and I'm going to multiply this entire equation by -2. When I do that, what ends up happening is the z's are going to eliminate. All right? And when I add, I'm going to have an equation with x and y in it. Now, sometimes you get a bonus, and a bonus is where either x or y eliminates also. So that's just kind of saves you an extra step. When I get this equation, I label it equation number 4, so I can keep track of it. So now what I have is, if you look at 3 and 4, I have two equations that both have an x and a y. I know how to solve two equations with the same two variables. And so I can either eliminate x or eliminate y. And what I'm going to do, I'm just going to choose to eliminate x by multiplying equation 3 by 3, -3. So I'm going to take equation number 3, multiply it by -3, and here's my revised equation. Then I'm going to take equation number 4, the way it is, and write it here with an arrow with no step on top of it. And I'm going to add those equations. This time, the x's eliminate. And now I know what y is. Everything from this point on is substitution. What I can do, go back to equation 3 or 4 and substitute y into that equation. So if I have -y equals +1, let's divide both sides by -1, and I have y equals -1. Now I can go back to 3 or 4, substitute y, and I'll find x. So I'm going to go back to, at the top here, equation 3. I'm just going to choose that. So that my teacher can follow what I'm going to do, I write a little number 3 next to it, so my teacher knows I'm using number 3 and can follow my work. And I'm going to write negative x plus 3 times negative 1, because y is negative 1, equals negative 4. That gives me negative x minus 3 equals negative 4. Add 3 to both sides. This gives me negative x equals negative 1. Divide both sides by negative 1. And this gives me x equals positive 1. Now I'm going to use substitution. I know what x is. I know what y is. Go back to one of your equations that has 3 variables, and it does not matter which one. So I'll just take, if we look up here, I'll take equation 1. And I could take 2. It'll come out the same way as long as they don't make a math error. So I'm going to write equation number 1 so my teacher can follow my work. And I'm going to write x, which is 1, minus 2 times y, which is negative 1, plus 2z equals 9. This gives me 1 plus 2 plus 2z equals 9. When I combine like terms, this gives me 3 plus 2z equals 9. Subtract 3 from both sides. And I have 2z equals 6. Divide both sides by 2. And that gives me z equals 3. Now I have found all 3 variables. I just need to put them in order in my answer. So x, y, z is 1, negative 1, 3 in alphabetical order. All right, let's try this again with another example. So let's go to page 11, and we have example number 5. And this time, we aren't missing any variables. So in other words, we don't have an easy way to start. So our first step has to be to decide what variable to eliminate. We can choose x, we can choose y, or we can choose z. And for this reason, each of us may do this problem differently. I think in this example, in my notes here, it says, I already decided to use equation 3 to eliminate x. So what I'm going to do is I'm going to eliminate x 2 times. That's going to give me 2 equations with y and z in them. So the first thing, let me label my equations. This is 1, this is 2, this is 3. And what I'll do for my first step is I'm going to use 1 and 3. And I'm going to multiply number 3 by negative 4. And that way I can eliminate x. So I'm writing equation 1 the way it is. Equation 3 times negative 4 will give me negative 4x minus 4y minus 4z equals 12. And what I'm going to do is add those together. What happens is the x's eliminate. I add my y's, I add my z's, and I add my constants. And this is a new equation for me, and I'm going to call it 4. Now I need to do this again. I've got to eliminate x again. Now I can use equation 1 and 2 or equation 2 and 3. It looks like what I've decided to do here is use equation 2 and 3. So if I use equation 2 and 3, what I want to do is take equation 3 and multiply it by negative 2, because I want to eliminate x again. I don't want to eliminate a different variable. I want to eliminate x again. All right, so I'm going to take equation 2 the way it is, and I'm going to take equation 3 and multiply it by negative 2. So I have negative 2x minus 2y minus 2z equals 6. And the x's are going to eliminate. And it gives me an equation with a bonus, because guess what else happens? Z eliminated itself. So I actually have an equation, negative 5y equals 15. This was a bonus. I can actually solve for y. So divide both sides by negative 5. And this is going to give me y equals negative 3. Once you've gotten one variable, it's all substitution from this point on. I'm going to go to equation number 4 and use substitution to find z. So I have negative 3, whoops, let me put a number 4 here so my teacher can follow my work. Negative 3 times y, which is negative 3, minus 7z equals 23. This gives me 9 minus 7z equals 23. Subtract 9 from both sides. And I've got negative 7z equals 14. Divide both sides by negative 7. And I've got z equals negative 2. Now I'm going to substitute into one of my original 3 equations and solve for my last variable, which is x, the one I eliminated first. It does not matter which equation I use. Usually I go for one that looks like it's easy to work with. So I'm going to choose number 3, x plus y plus z equals negative 3, because that looks easy to work with. So I'm going to go down here and I'm going to write a number 3, and I'm going to use substitution. So I have x plus y, which is negative 3, plus z, which is negative 2, equals negative 3. Combine like terms, and I have x minus 5 equals negative 3. Add 5 to both sides. And I have x equals 2. Now I'm going to fill in my solution. X is 2, y was negative 3, z was negative 2. And this is my solution. All right, let's do one more example. This one happens to be missing variables all over the place. This can be helpful for us because it can save us steps. I still need to decide which variable I'm going to eliminate. I have one with x eliminated, one with y eliminated, and one with z eliminated. I'm going to need to eliminate, I need 2 equations that have the same 2 variables in them, is what I need. So let's see what I chose here. It says choose any variable to eliminate twice. I choose y. You could choose x, you could choose z. It is not incorrect, it's just a different path to the end. So following that, we need 2 equations with the same 2 variables. I already decided to eliminate y, so I have to use equations 2 and 3 because they're the ones that have y's in them. So label my equations. This is 1, this is 2, this is 3. I'm going to use 2 the way it is and write it out. And equation 3, I'm going to multiply by negative 1 to eliminate y. So when I do that, and I'm writing everything so that my x's are vertically aligned, my y's are vertically aligned, and my z's are vertically aligned, so it makes it easy to add. So if I multiply 3z times negative 1, I get negative 3z, then, or I'm sorry, 3y, then plus 4z, and that's going to equal negative 4. My next step is to add those together. When I do that, my y's are going to eliminate, and I have 5x plus 4z equals 0. This is a new equation for me. I'm going to call it number 4. Now, I have another one with these same 2 variables, x and z, and that is number 1. So what I'm going to do now is I'm going to solve the system of number 1 and number 4 together. I'll solve for x, I'll solve for z, and I'll have those 2 variables. So what I'm going to do is I've got to choose now to either eliminate x or eliminate z. All right, so let's see what I've decided to do here is I've decided to eliminate z. So I'm taking equation number 1 and I'm going to multiply it by -2. So I have negative 4x minus 4z equals -4. Now I'm going to take number 4 the way it is, and that is 5x plus 4z equals 0. And I'm going to add these, and the z's are eliminating. Negative 4x plus 5x gives me 1x equals -4. Now I've got x. I can solve for other variables using substitution. So let me go back to that equation number 1 that I was working with. It had 2 times x, so 2 times -4 plus 2z equals 2. This gives me -8 plus 2z equals 2. Add 8 to both sides. And I have 2z equals 10. Divide both sides by 2, and I'm going to get z equals 5. So I've got another variable. Now I have x and z. I can take x and z and go to another equation and solve for y. I can use equation 2 or equation 3. I'm going to choose to use equation 2. You can choose whatever you like. So I'm going to write down equation number 2, and I start with 5x, which is 5 times -4 plus 3y equals 4. This gives me -20 plus 3y equals 4. Add 20 to both sides. This gives me 3y equals 24. Divide both sides by 3, and I have y equals 8. So let's go back and plug in all our solutions. X is -4, y is 8, z is 5.